Hey, everybody. Fascinating chat today. As we know, AI is not just pushing data centers harder, it's changing the way they're reimagined, redesigned, run, and more. Today, we have quite an innovator in this space at Edgecore. Tom, how are you?
Good morning, good afternoon, Evan. Real pleasure to be. Uh, I fit into the category of a longtime listener, first time caller.
Oh, thanks for joining. And you guys are right in the middle of this extraordinary shift, helping design this new digital backbone. Very exciting. Before that, how would you introduce Edgecore to the viewers, listeners these days, and what is your role in the company?
Sure. So Edgecore Digital Infrastructure, we are really a pure play data center owner operator developer focused on the hyperscale market, but increasingly this is the hyperscale plus AI frontier model market. We build single tenant buildings and campuses that are really designed to support when you put it very simply, the NVIDIA roadmap. We're supporting the current generation of hardware and beyond, and really positioning ourselves for all manner of other GPUs that will be rivaling the NVIDIA platform. What that ultimately means is, in our age of AI, is larger, uh, sort of scale out facilities and campuses,
Mm.
but also scale up facilities that are enabling the density that a modern generative AI wants. So my role with the company, I've been here since the early days. We've kind of lived, our first life and a second life in this age of AI from a more of a build to suit, I would say, almost a land and power developer to as we worked our way through COVID and supply chain challenges and really emerged out of that in this age of AI. We recognized that we really needed to build a foundational platform. We needed a product, and that product, I'd say, is generally 80 to 90% of what hyperscalers build, and then we do that last customization. My role has evolved in a couple of areas. It's now SVP of Emerging Technologies, and if I put that very simply, it's spending a lot of time on the downstream implications of AI and the technology revolution that we're seeing from GPU architectures, from CPU ones. And my background, I've been in the data center industry for over 20 years now. A commercial real estate convert. I that believed that that email and the internet wasn't going away in 2003. So I had the good fortune to peek behind the hood of infrastructure and what was carrier hotels and interconnection hubs, and I thought that was pretty cool, and I wanted to continue that. And I've been through a few technology cycles, I'd say, but along the way, I also did a stint at so I worked on this developer side before, on the advisory side, but very meaningfully was with Amazon Web Services for 4.5, 5 years in a new regions, basically export the cloud around the world sort of role that was really rounded out a perspective on what are the fundamentals of what's required. And we are in this new normal. There's some new fundamentals, new rules, new architectures for AI that we are positioning ourselves around while simultaneously supporting a great big old cloud business that continues to be very successful as well.
Amazing. So, a lot to unpack there. As you see
Sure.
firsthand, AIs are putting all kinds of new demands on infrastructure. So, how does that change the way you think about the way data centers are designed from the start? The sort of
Yep.
greenfield approach. What does that look like today?
Yeah, great example for our business. In 2018, we were very much positioned around cloud campuses, supporting the growth for key hyperscalers, and also that was a universe where for this single tenant building or campus model, 5 years ago there was 3 to 4 customers to really to really build towards. Now that's increased to about 10 to 15, and what I alluded to before, or Phoenix, Arizona, or specifically Mesa, Arizona East Valley campus was a campus originally 300 plus utility megawatts. We originally designed it for 5 to 6 buildings, 20 to 30 megawatts per building, kind of
Mm,
trying to find a sweet spot in that and that was what hyperscalers were looking for, 5 to 7 years ago. Now, and when we uh, found a new financial sponsor and partners group in November 22, one of the first things we did was, ChatGPT launches that same month, and the promise of generative AI and the demands were made material, and we remaster planned the campus. So we went from 6 to 3, the smallest
mm,
building being the first one. So now it's 72 megawatts, 108 megawatts, and these are, comparatively, 100 megawatt data center is,
wow.
for a current Blackwell system, that's a 50,000 GPU cluster, right? And as we hear about 100,000 GPU clusters and beyond, that's the sort of scale that's required. So we've positioned these buildings to support that. So the scale out, you can stitch these buildings together to support a big cluster, but also the scale up density. Um, the wonderful thing about NVLink is that you can stitch together, 72 GPUs in a rack, and the cost, your relative cost and performance benefits of copper, are tremendous. Not moving to optics just yet. However, the distance latency is about a meter, so it
Mm,
doesn't it it works great within a very small form factor, and that's really what's been pushing the need for direct-to-chip liquid cooling, which I think has gone from a niche application in the corner of traditional data centers or national labs to very quickly the baseline, capability that's required, because that rack, to meet its performance, needs to those 72 GPUs need to be within a meter's distance, and they are simultaneously getting denser. I
mm,
learned about the breakdown of Dennard scaling a couple of weeks ago, and basically that started happening in 2005,
mm.
and the transistor, we're bottlenecking at the limits of physics, where we're putting more transistors on these chips, but it stopped being fractionally more efficient. It's now you just need to add more chips. If you want more transistors, you need to, add more surface area and power. So, so we need to support that thermal envelope with the most modern applications. That's, simply put, you're running a fluid over a cold plate in this latest hardware. And once you do that, then we're pretty well positioned for the future. The roadmap that'll double from 150 kilowatts a rack today to 300 to up to upwards of a megawatt. And Google's already shown, that I think now that Google's lifted up the hood, we see that Google's been direct to chip liquid cooled or managed that for the last 7 to 10 years. So infrastructure becomes a competitive advantage. Um, Conversely, if you're not positioned, then you're using last year's model, right? Which is a reduction in the sort of aggregate teraflops that, per watt and efficiency, which is all part of you know, the game here for some of the big models and inference going forward.
Yeah, fascinating times. So we seem to be moving from one bottleneck or choke point to the next. You mentioned compute, seem to be getting over that hurdle, but then you get networking challenges, power, cooling. What's the choke point now that you're most focused on this quarter, next quarter, and beyond?
Yeah, we have our domain, right? So within our slice of this all, um, we a big way that we solve for supply chain challenges and power and the like is investment. Capital solves a lot. So we have got a great financial sponsor that's helped us really make the most out of these campuses. I would say that we're in execution mode. We're delivering buildings, leases that were executed, 1, 2 years ago. So that's all high tension, but we've got great partners helps, and also having the capital. I'd say just as important seems to be looking ahead,
Mm,
understanding, in these future campuses, can we secure the power that's required on a timely fashion to support the needs of our customers. And I think that at a macro level, that also becomes, I think that's writ large what the industry is concerned about. Um, you know, all the air. We're in the midst of conference season here, and Oracle earnings sucked all the air out of the room. Last week, and what we look at is unpacking. What is a $300 billion over 5 year deal, 5 years deal with OpenAI look like? And data centers are a meaningful part of that. I think a wet thumb analysis is, if Oracle spends 160 billion in chips, it's going to be 40 billion of data center spend on top of that. Now, some of that's going to be direct Oracle, some of that's going to be really leased from our industry,
mm,
and um, really it's going to be across a power footprint of estimated 4.5 gigawatts. Denver, the metropolitan area of Denver, requires about a gigawatt. Manhattan is about 11 gigawatts. So,
mm.
we're somewhere in between that development of a not quite Manhattan, but bigger than Denver, size city, in terms of power, and it's not sitting off the shelf, right? So I think where the easy electrons are gone, it requires, both partnership with utilities, but also some new and novel ways. I think there's going to be in all of the above approach to try and execute. And I'd say that's the biggest, you know, I'm fairly confident, barring a geopolitical
Mhm.
event like China invading Taiwan, that Oracle's going to be able to get the chips. Can they get the power and facilities to house those chips, in time for that? And OpenAI is not done, and Anthropic's also seeking, sort of gigawatt scale as well. So all these frontier models have converged on more compute is good, and enabling, you know, Elon and XAI, that wasn't 18 months ago, that wasn't a product. And by throwing raw compute they've entered the arena. And I think that's, at this, we're in the Clash of the Titans sort of scaling, among the set, and it's existential, and it's about who becomes the next Google, if we think from a search standpoint, platform wise. Um, but yeah, we're trying to support it. We're trying to get creative where needed, to make sure that the electrons are flowing, and then thereby the chips can run.
Brilliant. And of course, the chips, the hardware, the AI models get all the media attention, but there are other exciting areas to this around new approaches to interconnect and fabrics that
Yes,
need to be reinvented, open networking and architectures. What are some of those topics that you're exploring as well?
indeed. We are at the bricks and mortar side of the equation,
Hmm.
but it is we've gone from, a universe where that historically has been in the domain of intra data center networking, structured cabling, which is in
Mm,
under 5% of the investment uh, universe. So it's really important for execution. It's there.
hmm.
But there's always seen as sort of tactical. It's late binding work. You get the techs on site to get it done. That is absolutely morphed in the age of large clusters to, it could be as much as, 30 to 40% of the hardware spend for a large
Wow.
cluster. So this, you're spend $20 billion on, GPUs, and you're spending a third of that on networking on top of it. And then, I've had the benefit of, some some good friends in the industry who play there that have taken me through what the marshaling of resources looks like for deploying around 100,000 GPU cluster, and it's building a small army in 60 days, and I suddenly need 1.8 million terminations. You start doing the math on there's one technician on each side of the cable as they're connecting each side, so marshaling 1,000 people in the matter of 60 days and making sure the cable's there to be terminated and precisely done. So the tiering, the logically speaking, it's when every GPU needs to speak to every GPU and have a multiple connections too. It's exponential, right? So I think there's a lot of opportunity there. I think we're still learning. Bricks and mortar wise, we create pathways. There's more ladder racking systems and pathways and redundancy than ever. We just reading about, or I was at a AI Infra Summit last week, and Meta effectively described how they re-architected a 5-building campus for a couple 100,000 GPUs, and a big part of that, it's new trenching, it's new fiber, it's new big throughput, but then within the rack level as well. So I think that's a really exciting space. I think we're on the we see the cables getting bigger and the support structures required, but we're unpacking, I think, those implications. One big thing, optical transceivers. They have a power budget, that is not just in that noise. It's not in that under 5%. 100,000 GPU cluster might need, that's 100 to 200 megawatts alone. You might need 40 megawatts of optical transceivers, which is a evolutionary leap from that under 2 megawatts sort of realm. So there's also, I think, a lot of opportunity that's being looked at. How do you, if you could, 40 megawatts of power is 20,000 GPUs. So if you can optimize around that, I think that was a big topic of, let's look at some better technologies that actually enables more, more productive, compute.
Indeed, and also powering and running AI at scale is burning a lot of energy, it turns out, and electricity is a finite commodity. How do you square that with all of these needs, and what are some of your strategies there around the energy side?
Sure. Yeah, I think there's been a perception. I think there's that the data center industry is coming and putting a tremendous amount of pressure on the grid and thereby the ratepayer, to effectively bankroll. And I think a lot of the clarification, I think that's worth providing is most data centers are fairly self-sufficient. The investment that we make in the power grid generally has, multiplier, if not beneficial effects. So I think the overall principle these days that we're very sensitive to is paying our own way. It's not going to be on the backs of the ratepayers. And one thing that I've been pretty focused on since the start of the year and kind of had my eye on for a while, there's something called what we're internally calling a sort of curtailment for capacity. So demand response programs that utilities have run for years, 2 decades old. So basically the idea is if the grid is stressed, when the grid operator will go around and ask folks if they can sort of reduce load. Now data centers would less so reduce load, they'd more so run on our backup systems, to give the grid some breathing room. But Duke University came out with a study earlier in the year that variety of calculations, but let's say the overall grid is about 1,000 gigawatts, and we're talking about all these gigawatt campuses. There's the Oracle OpenAI requirement may need 4.5 to 5 gigawatts. Well, if we were to curtail, so I'll give a stat that lead this: 90% of the hours in a year for 90% of the hours in the year, we use about 60 to 70% of the grid capacity. So really, there's 30 to 40% of grid headroom that's for the extreme days, extreme weather events, generally weather, to so that the grid doesn't fall over. Our backup systems, if we were to reduce or reduce that top line by 1%, and the study points to us being able to shake loose over 100 gigawatts of power. So that turns into revenue generating capacity for the grid that offsets concerns for ratepayers, right? That's billions of dollars of revenue potentially to utilities. But I'd say that one of the challenges is an overall, it hasn't been done before. And I'd say that data centers really are about reliability and resiliency, and show me, there can be a herd mentality. Show me 20 folks that have done it first. So there's I say the logic of demand response in an era of abundant power didn't really make sense, and the economic incentives weren't there. In the times of increasing scarcity, I think the data center industry is sitting on gigawatts of backup generation, capacity that can help alleviate grid stress. And I think that's actually, I think that overall the industry should be very focused there, right? And I think it's actually, surprisingly, I think there's some real win-win potential there as well. And in also addressing some of the community concerns about rates going up because more investment is required. And I just say, we're in a position, I think, increasingly to use our infrastructure and actually help the grid run better.
That's a great point, and that's even considering all the investments in new energy modalities and fusion. We're getting closer, of course, renewables, but also, all kinds of new battery technologies are coming online. A lot of that investment is happening through our industry. So really exciting things to come. New
Absolutely.
nuclear
Yeah.
design approaches that are safer.
Yeah.
And beyond that, what are you excited about over the next few weeks and months? What's on your
Uh,
radar, you and the team?
I'm excited to stop traveling at the end of this week. It's been a blitz of the last 2 weeks, and to poke my industry a little bit, I'd suggest that they talk to each other a little bit more on the conference circuit. We've got a lot of overlapping bookings. I think we're interested in every week, every month gets a little different. There's the moves and the evolutions in terms of our AI moment. It's exciting on a weekly, monthly basis. I do think where we as bricks and mortar really infrastructure and real estate developers, we get excited about bricks and mortar news, right? Can we secure power on a time frame that's relevant? Can we if we come up with a creative solution to bridge, where we may have the power ultimately from the grid, but we may need to get a little more creative near term. And I'd say that our customer base, when I was at Amazon, I'd say that and I think this is common across a lot of hyperscalers, if you were leasing from a third party, it was a failure of the business to execute on their own behalf. And I think that's really evolved to we're a continuum of the supply chain. Somewhere like Stargate Abilene is this wedding cake of participants, and the Oracle probably cuts the biggest check of $40 billion. There's $15 to $20 billion of enabling investment underneath that, and one doesn't happen without the other. So we're looking forward to really being part of this big wave. I think listening to your show is a great way to stitch this these big megawatts and gigawatts abstraction to frankly, how is this really transforming industries and operations? And then I like to pull some, some tidbits that are sometimes helpful for my day-to-day business operations here too. But yeah, there's blank canvases everywhere, and I think that's what's so exciting about the sector right now, is that
Oh,
we're producing at intelligence. It's I've been playing with the concept of electroalchemy, and it's where energy on one side meets chips, and our output of tokens and intelligence is on the other. It's the modern gold, gold from energy. So, but you need chips in between. So
love it. Love
we're
the
on one side of it.
analogy. Although this actually works, whereas alchemy, we never quite got there.
We never
But
quite got there. Yeah.
but this is an amazing journey you're on, and I appreciate the insights and the update, including while you're on the road. Much appreciated.
Indeed. Thank you so much,
All
Evan.
right.
Really appreciate it.
Thank you.
Take care.
Thanks for joining. And thanks everyone for listening and sharing the episode. And check out our new TV show, Tech Impact, on Bloomberg and Fox Business. Thanks. Thanks, everyone.